Hello students, in this session we will study concept of how to find the square roots of complex numbers, then how to find value of polynomial at the given complex number, then we will solve the quadratic equation in which coefficients are real numbers or complex numbers also. So firstly we will discuss about method to find square roots. Method to find square root of complex number. So let a plus ib be square root of x plus iy. Therefore, square root of x plus iy is equal to a plus ib. So what we'll do here, we'll take the square on both sides. So therefore, x plus iy bracket square is equal to x plus iy is equal to a plus ib bracket square. Squaring this, we'll get a square plus 2bi plus ib bracket square, I square is minus 1. So we'll get a square minus b square plus, here 2abi, since I square is minus 1. Comparing real and imaginary parts. So this is your x plus iy. Comparing x with this, y with this. Okay. Comparing real and imaginary parts, we have x is equal to a square minus b square and y is equal to 2ab. This is my equation number 1 say, and this is 2. From 2, y is equal to 2ab, means I will find b is equal to say y upon 2a. Okay, y upon 2a, will substitute that value. A square minus b square is equal to x. So we'll put b is equal to y upon 2a here. X is equal to a square minus b square. And therefore, a square minus b square is nothing but y upon 2a bracket square is equal to x. Simplifying this as y square upon 4a square, we will get 4 times a raised to 4 minus y square is equal to 4 times a square x square. 4 times a square x. Taking this term here, we will get 4 a raised to 4 minus 4a square x minus y square is equal to 0. Substitute a square is equal to t. Then we will get this to be 4t square minus 4xt minus y square is equal to 0. This is quadratic equation in t. Solve it and take positive value of t, non-negative value of t, since t is equal to a square greater than or equal 0. Substitute this value, we will get value of t, then t is equal to a square is equal to t greater than or equal 0, and therefore a is equal to plus minus root t. Substitute this value in b equal to y upon 3a. substitute this value. Substitute t is equal to plus minus root t in 3 to get b. And then a plus ib gives square roots of x plus iy. So now we'll use this method to find the square roots of complex numbers. Okay, so take the example, find square roots of, say we'll take example 7 plus 24i. Let square root of 7 plus 24i is equal to a plus ib. We'll take it as a plus ib. Taking squaring both sides, we get yes is squaring both sides. We'll get 7 plus 24i is equal to a plus ib bracket square, and this is nothing but a square minus b square plus 2abi, which implies a square minus b square is equal to 7. Okay, this is 7, this is 2, and 2ab is equal to 24. This is 3. From 3, take b or a. B is equal to 24 upon 2a. 24 upon 2a is nothing but 12 by a. Use 4 in 2. We get a square minus b is nothing but 12 by a bracket square is equal to 7. This is nothing but a square minus 144 upon a square is equal to 7, and therefore a raised to 4 minus 144 is equal to 7a square. So we'll get a raised to 4 minus 7a square minus 144 is equal to 0. Now factors, we have to factorize this. A raised to 4, either put a square is t or keep it as it is. Assume this is the quadratic equation in a raised to 2. So minus 9a square plus 7a square. 16 nines are 124. And addition, minus 16 plus 9 gives us minus 7. Okay. Minus 144 is 0. Minus 16 plus 9 is equal to minus 7, and minus 16 into 9 is equal to minus 144. Addition of this is nothing but minus 7, and the product is constant term. Okay. So in this way we will get this. Taking a square outside, we will get a square minus 16. From this we will take 9 outside. We will get a square minus 16 is equal to 0. And therefore we will get a square minus 16 into a square plus 9 is equal to 0. Therefore a square is equal to 16. By comparing this equal to 0, a square plus 9 is equal to minus 9. This is not possible. This is possible. Since a belongs to R, implies a square is positive. Square of any real number is greater or equal 0, and therefore a square is equal to minus 9 is impossible. Therefore a square is equal to 16. Taking square root, a is equal to plus minus 4. Okay. Now b is equal to 12 by a by 4. Okay. So for a equal to 4, b is equal to 12 by 4, which is equal to 3. And therefore a plus ib is equal to 4 plus 3i. For a is equal to minus 4, b is equal to 12 upon minus 4 is equal to minus 3, and therefore a plus ib is equal to minus 4 minus 3i. Minus 4 minus 3i. So from this, square root of which number we have taken? 7 plus 24i is equal to 4 plus 3i or minus 4 minus 3i. So there are two solutions. There are two solutions for square roots. For real number also we get two square roots. One is positive, one is negative, except 0. So this is a simple technique to find square roots. For your practice, we'll take one more example. Say, find square root of say minus 8 minus 6i. So write square root of minus 8 minus 6i is equal to again a plus ib. Squaring both sides will get a plus ib bracket square is equal to minus 8 minus 6i, and this simplifying will get a square minus b square. Remember this formula always, plus 2abi is equal to minus 8 minus 6i. So this is your real part, this is your imaginary part, this is your real, this is your imaginary part. This implies a square minus b square is equal to minus 8. This is say 1, this is 2, and 2ab is equal to minus 6. This is 3. Okay. So from 3, what is your b? B is equal to minus 6 upon 2a. Substituting this value in 2, we get a square minus 6 upon 2a bracket square is equal to minus 8. Then we'll get 4a raised to 4 minus, this is your minus 6 bracket square is 36 is equal to, and taking this 4a square on this side, minus 8 into 4a square. So we'll get 4a raised to 4 plus 32 a square minus 36 is equal to 0. This is nothing but 36 upon 4a square. Actually, I can simplify it as okay. Now we'll take 4 outside. We'll take here 4 outside. Otherwise, first you can take 36 upon 4. That is 9. That is 9. Now taking 4 outside, we'll get. So multiplying by 1 by 4, we'll get a raised to 4 minus plus, if I divide 32 by 4, 4 eighths, 8a square minus 9 is equal to 0. Quadratic equation in a square. Don't put a square is equal to t, not necessary. So now I want addition to be 8, product to be minus 9. So one term is negative, one is positive. In which for splitting 8 or getting that two terms, greater number has positive sign and smaller number has negative sign. So we'll get a raised to 4 plus 9a square minus a square minus 9 is equal to 0. Taking a square outside, a square plus 9 plus minus a square in bracket, a square plus 9 is, sorry, here 1. So we'll get a square plus 9 into a square minus 1 is equal to 0. This implies a square plus 9 is equal to 0, a square minus 1 is equal to 0. Therefore, a square is equal to minus 9 is not possible. Okay, and a square is equal to 1, it is possible. Since a square is greater than or equal to 0 for any a belongs to R, and therefore a is equal to plus minus 1. A equal to plus minus 1. Okay. Now b is equal to minus 6 upon 2a. So for a is equal to 1, b is equal to minus 6 upon 2, which is nothing but minus 3. And therefore a plus ib is equal to, immediately write a plus ib, that is 1 minus 3i. Okay. For a equal to minus 1, your b is minus 6 upon minus 2, which is nothing but 3, implies a plus ib is equal to minus 1 plus 3i. And therefore, square root of a plus ib minus 8 minus 6i, which is equal to a plus ib is equal to 1 minus 3i or minus 1 plus 3i. Okay. So there exist two square roots. In fact, if you take and here, both are the square roots. Both are square roots. Now we'll study how to solve quadratic equations. Quadratic equations. X square plus bx plus c is equal to 0. A not equal to 0. This is quadratic equation form. Roots of quadratic equation. Roots are given by x is equal to minus b plus minus under root of b square minus 4ac divided by 2a, where 1 del is equal to discriminant del is equal to b square minus 4ac greater than 0, implies equation has real and distinct roots. Second, del is equal to 0 implies equation has real repeated roots. Only one root. And third, if del less than 0 implies equation has complex roots. Now here this b square minus 4ac is negative, means its square root is nothing but complex number something into I plus minus I minus b, this 2a, that is fixed numbers, and due to that, okay, ABC belongs to R with real coefficients. This is one. Okay. So this equation has complex roots which are in complex conjugate pairs. We also know that, note, if alpha beta roots of quadratic equation, alpha beta are roots of ax square plus bx plus c is equal to 0, then alpha plus beta is equal to minus b upon a and alpha beta is equal to c upon a. This is very useful technique for objective questions. If I have a question like this, which of following are the roots of quadratic equation? And they will give pairs, two pairs. If I have to solve, then by factorization method or completion of square method or formula method also. It takes a lot of time. So in your answer, check alpha plus beta and minus b upon a. If that coincide, that is equal only in one option, then that is the correct option. In some option, in two options, alpha plus beta coincide with minus b by a, then you have to check one more option where alpha beta is also c by a. Alpha beta is also c by a. So this is the way of checking whether roots of quadratic equation from multiple choices questions are correct or not. Even though this formula is true for quadratic equation with real coefficients, here we are going to find solutions of quadratic equation with complex coefficients. For complex coefficients also, this result is true. For complex coefficient also, this result is true. You can apply this result to check whether which is the correct option for roots of given quadratic equation. Okay, so this is one more important about the quadratic equation, and that quadratic equations also plays one more important role. If del is less than 0, del less than 0, if I have polynomial equation, say a naught plus a1x plus a2x square plus dot dot up to an x raised to n, where a naught, a1 dot dot up to an are real numbers and a not equal to 0. Okay, is polynomial of degree n, polynomial of degree n. Okay, then fundamental theorem of algebra tells us that this equation has exactly n roots in complex numbers. Okay, then if x is equal to 0 has exactly n roots in C. Okay, so this is the result. Say exactly n roots in C. If n is odd integer, if polynomial is of degree odd n, if n is odd and complex roots occurs in pairs, if a plus ib is one root, then a minus ib is also root. So complex roots always occurs in pairs. Suppose this is polynomial of degree 9. It has exactly 9 roots. Complex roots occurs in pairs, means say first root is complex, then its complex conjugate is a complex root. Second is one more complex root, its root is also complex conjugate is root. So 4 roots are complex numbers. Is it right? And then remaining roots may be real roots. As complex roots occurs in pairs, so any polynomial of odd degree has at least one root. That is one important note about this polynomial equation. What is one more the result about this polynomial equation? Quadratic equation has complex roots in pair. So if x is equal to alpha is root, then minus alpha, alpha bar is root, implies x minus alpha and x minus alpha bar are factors of fx, If these are factors, this implies the product x minus alpha into x minus alpha bar is factor of fx, which is nothing but x square minus alpha plus alpha bar x plus alpha alpha bar. This quadratic polynomial is factor of this nth degree polynomial. So if I divide that polynomial by that, power of this polynomial will get decreased. So here quotient will become of degree n minus 2 then. Again for n minus 2 degree, again we'll find one complex roots. With help that we'll get other complex root. We'll go on finding complex roots in this way. So that is one technique for finding roots of polynomial with real coefficients. Okay. So we'll take examples on this now. So find value of fx. Find value of f of x is equal to, say, if I take the question x cube minus x square plus x plus 46, when x is equal to 2 plus 3i. Okay. You have to find out f of 2 plus 3i. So what is one way one can substitute 2 plus 3i here? Then you have to expand 2 plus 3i cube, 2 plus 3i square. Is it right? If I have fourth degree polynomial, 5x raised to 4 plus x cube minus x square, this is given. Then how to find that value? Okay. So here we have to find out this one. Okay. So here fx is equal to x cube minus x square plus x plus 46. X is equal to 2 plus 3i. Therefore, x bar is equal to 2 minus 3i. Therefore, if I take this as, say, alpha, this as alpha, implies alpha bar is equal to this. Implies x minus alpha into x minus alpha bar is equal to x square minus alpha plus alpha bar x plus alpha into alpha bar. If I expand this, x square minus alpha bar x minus alpha x plus alpha into alpha bar. Now for this 2 plus 3i, this is my alpha. So we'll get x square. What is addition of these two numbers? Alpha plus alpha bar. Imaginary part get cancel. 4x. We know that a plus ib into a minus ib is nothing but a square plus b square plus a square minus b square. A square plus b square, 2 square plus 3 square. So we'll get x square minus 4x plus 4 plus 9, that is 13. that is 13. Okay. Take this polynomial as gx. Take this polynomial as gx. What is your gx? X minus alpha into x minus alpha bar. Gx is nothing but x minus alpha into x minus alpha bar. Divide fx by gx. Usual way. What is fx? X cube minus x square plus x plus 46. Gx is x square minus 4x plus 13. X cube, so multiply by x. X into x cube, x square, x cube minus 4x square plus 13x. Minus plus minus. X cube get cancelled. 4x square minus x square, 3x square minus 13x plus x, that is 12x. We'll take 46 from above. Then we'll multiply this by 3x. 3 only. Only 3. So what we'll get? 3x square minus 12x plus 39. Minus plus minus. This get cancelled, this get cancelled. 46 minus 39, this is your 7. Okay. Now, dividend is equal to divisor into quotient plus remainder. This implies is, therefore fx is equal to, what is your divisor? Gx into quotient is x plus 3. This is your say qx quotient. Okay. Or I can write it there gx also. X plus 3 plus remainder is 7. Therefore, f of alpha is equal to g of alpha into alpha plus 3 plus 7. Okay. So, give 1 for this. Now, g alpha is equal to x minus alpha, okay, x minus alpha bar at x equal to alpha is nothing but alpha minus alpha into alpha minus alpha bar. This is 0. G alpha is 0. Okay. And therefore, f of alpha is equal to 0 into alpha plus 3 plus 7. And therefore, f of 2 plus 3i is equal to 7. Is equal to 7. Now, for this cubic polynomial, you can say that in given polynomial, cubic polynomial, if I put x is equal to this value directly, by taking expanding 2 plus 3i cube by using the formula a plus b bracket cube for square, simplifying, you will get the same answer. You will get same answer. But this technique is very useful while solving or finding value of f of alpha, where degree of fx is greater or equal 4. Degree of fx is 4, 5, 6, 7, etc. Then in that case, this technique is very useful. You have studied synthetic division method. Okay. Synthetic division or by synthetic division. What you are doing, you are taking coefficients of fx 1, then minus 1, 1, 46. and here alpha is equal to or x equal to 2 plus 3i. Then what you are doing, you are taking 1 here, you are taking multiplication here, 2 plus 3i, then you are taking their addition, minus 1 plus 2, that is 1 plus 3i, taking product of these two now. This is 2, 3i into 3i, 3i into 3i, that will become 9i square, 9i square minus, so 2 minus 9, that is minus 7, and then 6i plus 3i, 6i plus 3i, 9i, correct? 2 into 3, 6i, plus 1 into 3, 3i. That gives us this one, 2 minus 9. Now take addition of these two, we'll get minus 6 plus 9i. Okay. Then take product of this, minus 12 and 3 into 9, 27, minus 27, so minus 12 minus 27, that is minus 39. Is it right? And if I take now, this is nothing but 9 2s are 18i, and this is nothing but 0i. So we will get 46 minus 39. This is your remainder. Okay. This implies is f of alpha, that is f of 2 plus 3i is equal to 7. This is your synthetic division technique. If this remainder becomes 0, then this is the root of that equation. This is root of that equation. So with this discussion, today we'll stop our session here. By next lecture, we'll take more examples on same topic and we'll explain fundamental theorem of algebra in detail, because that is very useful for CET exam, then JEE exam, etc., competitive exam. Thanks. Bye-bye.